Okay, a block of mass m acted on by a force of magnitude F directed horizontally to the right as shown above slides up an inclined plane that makes an angle theta with the horizontal. The coefficient of sliding friction between the block and the plane is mu. In the diagram of the block below, draw and label all the forces that act on the block as it slides up the plane. Okay, we have a block. Alright, so this is the force normal because it's perpendicular to the surface, and then this will be our weight force, which is just directly down from the center of the object. This direction is the applied force, which is used to direct the object, or in this case the block, upward, and this is the force friction. Alright, I think I went too fast. Okay, so this force normal, which is perpendicular to the surface. This is your weight force, going straight down. That's your normal force. Also, this is your force applied, right here. I don't know why they did this, that's confusing. This is your force normal, and this will be your force friction. That's because this is where force applied goes, and this is force friction. And the reason force friction is the opposite is because friction is always opposite the direction of motion, and that's why it's like this. And we're on to part B. A block of mass m acted on by a force of magnitude. Oh wait, I'm reading it again. Alright, develop an expression in terms of m, theta, m, theta, f, mu, and g for the block's acceleration up the plane. Fun. Alright, what do they want? Alright, okay, see what it is. Alright, you know that, say this is the coordinate axis. That's where your force normal is going to point. That's where your force applied sine theta is going to point. And that's where your mg cosine theta is going to point. Cosine theta. That's where that's going to point. And these are your these are the forces acting in your vertical direction. And all of this is going to equal to 0 because this has to match that. So these will all be equal to 0. So the force in the y direction is going to equal, or it is ultimately going to equal 0. So in order for us to get, what do they want? Oh yeah, so in order for us to get MA, we gotta do some manipulation. So we get all the forces in our vertical direction. We have normal force minus F sine theta, which is pointing down, and minus mg cosine theta, which is also pointing down. So that will all equal to 0. So when you do these again, you know that F equals MA. And you know this is going to be your force. When you isolate all of these and bring them to the other side, you know that the newtons is going to be equal to the force of sine theta and plus mg cosine theta. Right? Okay, so there's that. So now we're going to deal with the forces in the x direction. So this way. We have mg sine theta going that way. We have force applied cos theta going this direction. And no, I'm sorry. Force applied cos theta is going to go this direction. And then last but not least, we have our friction force, which is going to be this way. Mg and then mu. Or I guess we can replace this by saying we can replace that by saying that times the normal force. And so what we want here is our MA. And so what we have here is have our our forces in the x direction. We have force applied cosine theta, which is positive because it's going in the direction of motion, minus our mg sine theta. We don't have space. Minus mg sine theta because it's going this way, minus our force friction, which is also going this way. But here we know that mu, or force of friction, is mu times normal force, right? But what we did previously is we isolated the normal force to get it in terms of the other forces. We got n equals up here. N equals F sine theta, or force applied sine theta, plus mg cosine theta. Right? That was what we got was equal to n. So we substitute that into the n over here. And we get F cosine theta minus mg sine theta minus mu times this expression, F sine theta, force applied sine theta, plus mg cosine theta. And all of that will equal to ma. So all we need to do for acceleration is divide it all by m. I'm going to delete this. So all we need to do now is a equals f cosine theta minus mg sine theta minus mu times force normal sine theta plus mg cosine theta. All of that divided by m. If you I might have gone a little bit fast, but if you want to digest this better, I would advise you to watch this a few more times to get the how did I or why did I do this. And that's it for part 1. And in the next video, I'm going to do centripetal forces. And that's it.